This is a demo of the NRCan developed web map custom element, which is available on GitHub. This version of the client shows the prototype implementation of MapML vector tiles, which are served by the Cherry OGC Features API MapML service. The MapML client is currently available in a feature branch and may be improved and released eventually. This map shows two layers served by Cherry. Both layers are shown here in the WGS84 based tiling scheme and coordinate system. Base layer is an image-based layer of tiled satellite imagery. The top layer is MapML vector tiles. Each tile matrix of vector tiles serves the content at a different resolution. The tile boundaries are included in these vectors wrapped in span elements. These tile boundaries become visually prominent when a lot of data is presented on screen. The objective of MapML is to integrate fundamentally with HTML. In effect, MapML is an extension of HTML and should be implemented using the same architectural patterns that the parent language is implemented with. This means that features such as the natural earth countries layer shown here should be stylable using CSS. In this case, the span elements which wrap the tile boundaries are tagged with the no-line class by the service provider. The service provider should eventually be able to provide style rules which govern the rendering behavior of the content. For example, I've created a CSS style sheet that styles each of the countries in a random color and outlines it in blue. By adding a CSS selector for the no-line class, I'm able to control the rendering of the tile boundaries. Which works pretty well, except for a few artifacts that are included in the source data. Let's now have a look at the MapML documents that are being processed in this demo. Here's the source HTML document that's being displayed in the demo. The HTML head element imports the web map custom element polyfill and supporting library code. This allows us to use the HTML custom elements that have become a standard feature in browsers to emulate native browser support for maps. This emulated support is not perfect, nor is it anywhere near as performant as one might expect native support for maps to be eventually. It does, however, give us a sense of what the HTML authoring experience might be like for maps and layers should they be implemented as MapML by browsers. The remote layers are most easily realized by using the f equals MapML service parameter at the collection URL level, as shown here. Each layer custom element has an optional source attribute, which can be used to reference a MapML document. In the case of a feature-based layer in this demo, the query links in the remote collection document are not optimal, and so I've bypassed that document by encoding the MapML extent element inline in the HTML document. This has the advantage of showing us what is useful in a MapML document at the collection level. The extent element contains link elements that represent the resources which compose the map layer. In the case of image-based tiles, the remote resources are actual image files, such as PNG or JPEGs. This is quite convenient for emulating browser support of maps, since images were the first non-text media type in HTML supported by browsers via the image element. As such, many map libraries, including the web map custom element, use many image elements visually arranged using CSS transforms to represent a map layer. For vector-based tile resources, the WebMap custom element client has been programmed to support the client-side transformation of tiles of MapML content to tiles of SVG and SVG namespace child elements, which are also visually arranged using CSS transforms. SVG has the benefit of having comprehensive support of CSS. CSS can style the SVG namespace child elements, which are created locally to represent geospatial features encoded in MapML. In the future, the map layer author should be able to provide CSS style sheets which target classes of feature elements and their children. This relationship is emulated in this demo by transforming those features into SVG. Testbed 15 MapML deliverables did not include styling requirements, and the creation of tiled MapML features was a bonus contribution. However, map tiles are meant to convey semantics via visualization, so styling is an important category of use case. In Testbed 14, participants developed a model of alternate styles for layers that was developed to support named styles of WMS and WMTS services. This is an example of using WMS name styles to underpin a MapML service. The markup to support this feature shown here is from GeoServer, but upon reflection could equally apply to features API collections. All that would be required would be to scope a style parameter or API path step to the MapML representation of the collection, allowing the collection to link to a particular name style to the collection via link rel equals self style. The alternate styles, if applicable, would be available for selection by the user in the manner shown here. To go a little bit down the road of how CSS could work with feature geometries in HTML or MapML, I created a CSS style sheet that targets the SVG content on the client, generated from feature geometries received from the service. Because of the native support emulation through transformation to SVG, the CSS targets classes on the generated elements because the geometry and related MapML child elements don't actually end up existing in the DOM. These classes are mostly copied from the source MapML features.